Hello, so plan with me. We're going to talk about Unit 1 Maths Methods, the 2025 version. I've been very lucky in the past to work in like packed math staff rooms with lots of maths teachers, and I've been able to collaborate on this kind of planning. However, today I'm just hanging out in my house at home, and I'm sort of going it solo here because I know a lot of other people in Queensland are going it solo as well, and planning this is kind of pretty scary. So I'm just going to plan it and talk through my thought process, show you some ideas, some thinking that I've got here. Yeah. Okay. So what am I doing? So I've got two documents open. I've just chopped up the Unit 1 syllabus. So that's the entirety of Unit 1 for 2025. And I've also created this little document here. So I'm going from week 1, term 1, week 10, then I've got my holidays, and then all the way down to week 16. So I'm thinking that's about half of the 3 terms that I'm going to do Unit 1 and Unit 2 in. Now, I might need to change this at some point. I might need to make it 1 week shorter or 1 week longer or something like that. But let's work off this idea. Now, you might be looking at it and thinking that my maths isn't good because I'm going down to week 16. Maybe I should only go down to week 15. I've got an idea in my head about why I'm taking a little bit longer on Unit 1 than Unit 2. So we'll talk about that as we go. Okay, so what else do I have? I've already done a little bit of work before starting this video, not too much. Now, I've obviously had to read through this and had a little think about what all of this looks like, but I've also done a little bit of Googling. So let's just open that up. Some late starts to terms, late starts there and there, a public holiday there, last day of term, so I'm guessing not much is going to happen, a public holiday here, and I've just assumed that we're going to have like a sports carnival here and here. You know, maybe there's another lost day somewhere. I'm also making that assumption that those sports carnivals are falling on my lessons. Speaking of which, oh, actually, what have I done next? Okay, so I've put in, and so I like to do this when I'm doing my planning. I like to build in like diagnostic tests and things like that. So I've built in a diagnostic test here. That might get moved around while I'm planning. I've built in a diagnostic test there. That might get moved around while I'm planning. Exam at the end of week 6, a week of revision, and a diagnostic at the end of week 10. You can see also I've filled in my PSMT week. So I like to do like a full week of explicit instruction when it comes to the PSMT in year 11. Lots of, now this is how you write assumptions, and this is how you write observations, and this is reasonableness, etc. And that's why also I'm allowing myself a little more time to get through Unit 1 than I am allowing myself to get through Unit 2, because I'm kind of taking a week off the teaching to talk about, do other teaching, do PSMT teaching. Okay, now I've kind of tried to up the difficulty as much as possible because I think maybe the most difficult thing to plan for would be 3 70-minute lessons. So 70-minute lesson on the Monday. You can see I'm going to lose a bunch because of these public holidays. 70-minute lesson on the Wednesday. You can see I'm going to lose a bunch because that's where I've strategically put my cross-country and my swimming carnival. And lessons on the Friday. I'm going to lose lessons there too. So sort of strategically chosen 3 70-minute lessons. That's quite hard to plan for, I think, but also put them on Monday, Wednesday, and Friday, kind of like a worst case scenario type thing. Maybe you think I'm still being too optimistic. I'm not sure, but I'm going to work with this for now. Okay, so I kind of added up how many lessons I've got. I've got 33 lessons. I've got way more than 33 dot points on the left-hand side. I'm not going to bother counting them, but I think there's about 50 or something. So I have to start with the knowledge that it's not as simple as just, oh, I'm going to do that dot point on this lesson and that dot point on this lesson. I have to combine dot points, but I think that makes sense as well because some of these dot points are like literally a 5-second conversation, not like a whole lesson. Another sort of driving principle here is that I am only looking at the syllabus, right? I'm not looking at the textbook. The textbook is a great resource. I like them, but for it to be a good resource, it should have more in it than the syllabus has. If it had less than the syllabus, that would be a big, big problem. You can't have exactly what's in the syllabus. That would be impossible to write. So textbooks should have more than what's in the syllabus. And it's going to be up to me to kind of not look at the textbook at all, instead focus on this syllabus and just teach each dot point as I understand it. That also goes the same for like my website, Maths Videos Australia. Those videos, there's way too many of them. I've made them over time for various purposes and various reasons. I put them up there because I think they're good resources for people. But if someone were to just go from the start to the finish, they would know too much stuff. They would repeat things, and like there's too much there. So I'm not going to even look at my own website. I can't remember all the videos that are on there, but I'm not going to look at that for my planning as well. The only thing I'm using for my planning is this document right here. Okay, let's get started. Surds. So this is the sort of thing I'm talking about. Understand the concept of a surd as an irrational number using a square root or a radical sign. That's like a 5-second conversation. I don't see that as like some big exploration of the, what an irrational number is and things like that. Simplify square roots of natural numbers, which contain perfect square factors. Rationalize and then use the 4 operations and some examples here. It's worth understanding context for this. This exists because in the previous syllabus it didn't exist, and the idea is that, hey, this is limiting us in our tech-free exams, particularly the external, because we can't ask the students to do a bunch of questions with surds and operate with surds because we never taught them surds. Surds isn't in the Year 10 curriculum, it's in the 10A curriculum, so it can't be kind of assumed knowledge. So they've put it here, right? But it's important to understand why it's here. It's here to support just basic operations. So you could do heaps of stuff on rationalizing denominators. You could do heaps of stuff simplifying. You could put algebraic surds in here, but they're not asking us to do algebraic surds. Specifically, they're saying square roots of natural numbers. That's all they're saying. So all of that is to say that I think I can do this, this, and this in a 70-minute lesson. As long as I'm not like adding a bunch of weirdness. Now you can see it looks very, very tiny here. Don't worry, it is there and it is like visible. And I can like make it bigger just by making my thing bigger. So, okay, so that's my first lesson. We come along, we walk in, we're keen to learn, set some ground rules, and then we're going to go, it's a 70-minute lesson, so we're going to spend 35 minutes doing simplifying surds, and then another 35 minutes rationalizing denominators. Feels like heaps of time. Walk out. I don't think we've got to do any homework today. And then it feels like this is my next 70-minute lesson. Whoops. And I don't think it's going to take any more than 70 minutes to do operations of surds. Think about what sorts of operations, when it comes to surds, that we're preparing them for. There's not a lot of times when you're like doing this kind of thing, but you can. Like really, you do a lot of multiplying surds and you do a lot of dividing surds. So that would be my major focus here. I'm going to limit the scope of this because I don't think I understand why it exists, and I'm going to teach the intent and the letter of the syllabus. The syllabus doesn't say to do much. Okay. So that's week 1. So week 1 is going to be surds, and we'll just knock over surds in 1 week, 2 lessons, and I think we're finished. Okay. Solve quadratic. This dot point here, it just feels like it's in the wrong spot to me. Like, I don't think I'm going to start there. I think I'm going to start here. Now, solving quadratic equations is definitely in the Year 10 syllabus, so they should be familiar with some of this, but I'm going to assume that they're not familiar with it. The reason I'm going to assume they're not familiar with it is because some of them may have come to my school, and so I don't know what they've done. But also, like, it's just such an important skill to have. So, and it's a big dot point as well. bit dangerous. So I think what I'm going to do is split up this dot point into 3 lessons, but I'm going to try to be pretty clever about it. So solve quadratic equations algebraically using factorization. So I think that's going to be a full lesson, but I'm going to do a few things here. So I've got to do factorization, I've got to do solving, so the null factor law. So I'm going to take that, but I've looked ahead in the syllabus a little bit, and what I notice is that there is a spot in the cubics bit where it says solve cubic equations using technology and algebraically in cases where the equation is factorized. So if I'm going to teach quadratics solving using factorization, it wouldn't be difficult at all to also teach them this times this times this in the same time when I'm teaching them the null factor law. I could do like 10 of them. It's all going to be the same deal. So I'm going to hit the cubic solving at the same time that I hit the quadratic solving because it's all null factor law. All right, so I think we're going to do these this is 1/3 of a dot point, and this is a full dot point from the cubics. So I'm going to do both of those, and I'm going to put them on my Monday lesson where I start quadratics. All right, so that's done. I've kind of done 3 things there. I've factorized using decomposition, the AC method. I've done the null factor law for quadratics and cubics, just in generally the null factor law. All right, now what are we going to do? We're going to do, completing the square. I think I should do completing the square next, because technically I don't feel okay with teaching the quadratic formula until I've done completing the square. So I'm going to do completing the square here. Okay, I'm going to paste that in this lesson. Now, it feels like I've got a bit of an opportunity here. I'm completing the square. I'm solving using completing the square. There is also this dot point sitting here that talks about like this thing here. So this might be an opportunity to talk a lot about like rearranging, if that's something I want to do, rearranging an equation that looks like this into an equation that looks like this. So that'll be kind of the 70-minute lesson, completing the square, solving completing the square, and like converting this to this. That feels good. I can kind of make mention of this. I'm not really hitting this dot point, I don't think yet. Okay, next up, I've got the quadratic formula, exact and approximate solutions. That's good. And so that's probably a good time for me to mention that I feel like, yes, I've only done 2 lessons on surds, but if I teach correctly, I can fit surds into literally any lesson. So we can keep doing like spaced practice by doing surds in quadratics or anything. So that's going to be another opportunity to do that. I also noticed that it says dot point, use the discriminant to determine the number of solutions to a quadratic equation. So I can do that dot point at the same time that I'm doing the quadratic formula here. All right, so roughly speaking, we're going to do quadratic formula and we're going to use the discriminant to determine the number of solutions to a quadratic equation. We're sort of hitting 1/3 of a dot point plus another full one in this lesson right here, this Friday lesson. Okay. So this is quadratics this week. And if we're sort of keeping score here, I've covered that dot point, it's in its entirety. I've covered this dot point. I sort of maybe mentioned this dot point, but I haven't pasted it into my working yet. And I also am like doing some sort of cubic one. I might just, for ease of like being able to deal with this, I might just delete all of the ones that I've done now. Okay, so next up, what have we got? Recognize and determine features of the graph, this, and this. Now, I think sometimes people can look at this dot point and see it as quite vague and they're not sure what they should be looking at. I think, what does this graph tell me? Well, it tells me the y-intercept. What does this graph tell me? It tells me the turning point. What does this graph tell me? It tells me the x-intercepts. I don't know how much more this dot point requires than that. I guess this one also sort of, you can determine the axis of symmetry quite quickly from this one. If you know the roots, you can determine the axis of symmetry quite quickly from this one, negative b on 2a. But this dot point feels like a stepping stone to just sketching the graphs of quadratic equations. Now, of course, if you are sketching the graphs of quadratic equations, you are also determining turning points and zeros, because you can't sketch a quadratic equation unless you're determining turning points and zeros of quadratic functions. So I'm going to put this, and this all in my next lesson, right? Right here. Now, it sounds big, but I think maybe the key here is that when you sketch functions, you're always doing the same thing, essentially. Let y equal 0, let x equal 0. Understand the general shape. Here, there's a new thing, like a turning point. But it's hopefully, if we spend some time here going, let y equal 0, let x equal 0, that's kind of key to sketching. Doesn't really matter too much. Now, interestingly, here, what I note is that there is no dot point that says something like, find the equation from a sketch. Now, do I want it in there? Maybe I do, but there are like, that's a really big topic. If you've ever done that one before, it can be really big because there are all sorts of different permutations where like, oh, well, the 3 dots are in random spots. So you do a different method for finding the equation, do a different method for finding the equation if you just know the x-intercepts at a random point, do something different for some other thing. So I think for now, I'm going to put a placeholder here that isn't a dot point, but is just like find the equation of from a sketch. And I feel like maybe I'll get rid of it later, but it's going to stay there for now. Okay, finally, we've got modeling and solving. Let's get rid of everything. We've got model and solve problems that involve quadratic functions with and without technology. So this is a modeling and problem solving type lesson. We'll put it here and we'll paste the picture into the cell. Okay, I just feel like, what am I thinking? I feel like I've got a diagnostic planned here for the Monday. Let's just leave it there for now, maybe. Let's just assume that we're going to do quadratics here, we're going to do quadratics here. And so I'll just build some fat into here because, you know, maybe it takes extra long to do sketching. So I'll just put fat. And we'll come back to that later. Maybe we'll need to like trim that fat, or maybe I'll think more about this. The diagnostic on Monday. This is our big first time for our year 11s. I feel like you've got to set them up for success here. So we've done surds, we've done quadratics. I'm going to do like it's a 70-minute lesson. So we're going to do like a 30-minute diagnostic and then mark it yourself kind of thing. That'll be the whole thing, handed in at the end. That way I'll have an idea of how they're going. We can start having conversations, things like that. Okay, what do we got? We can get rid of model and solve problems. Oh, I should mention, model and solve problems, that is sufficiently vague that you could decide what you think model and solve problems is. But I think finding questions, if you're familiar with optimization in year 12, finding modeling and problem solving questions that prep them for their ability to do optimization questions. So being able to like look at a question and create a quadratic equation from the question. I hope that makes sense. I think that's an important skill. Also just being able to look at an equation and find out, they give you the equation of a projectile or something and you find when it's highest, when it hits the ground. Being able to state that it's like an x-intercept or a y-intercept, I think that's good. So maybe the fat isn't fat. Maybe this is more modeling but maybe also it's more sketching equations. Like maybe this needs to be put across 2 lessons. Probably depends upon our clientele, let's say. Okay, so diagnostics here. The next up, it's binomial expansion. Understand the notion of a combination as an unordered set of R objects taken from a set of N distinct objects. Pascal's triangle and this notation, and then use the binomial theorem to expand expressions. All right, you want to be careful here that you don't go way too far, right? It might be worth opening up the specialist syllabus, even if you don't teach specialist, so you can see how far we go when it comes to combinations. We do a whole unit on combinations. We do heaps and heaps and heaps of stuff. That is not your requirement here, right? Like, you don't need to do like heaps and heaps and heaps of work on combinations. So I really think that like this whole thing is a 70-minute lesson, right? Now, if you like look into the future, what are we using this for? Well, we're using this for binomial probability in like unit 3 or 4, whenever that's happening in the new syllabus. We're kind of using that for binomial probability as well if we've got to do something tech-free. And then I think this sort of culminates in this bit here. An interesting kind of like question to test that they can do this is just like giving them like a really wild big bracket, 2x minus y to the 12 or something, and asking them like, what's the 7th term or something. If they can do that, then I would say that this, maybe that's going to be too big. Maybe the number's going to be too big. Maybe we should just make it like 6 and ask them 4th term or something. But if they can do that, I feel like they can do what they need to do. They can locate NR on Pascal's triangle, and then they can expand this. If they can find the nth term, they can follow this formula, which is basically what we need. I think they can follow this formula, which is basically what I think they need to do. So I think it's a single lesson. I don't think there's any more time that you should spend there. They've put 3 hours down for it. I'm going to knock it over in 70 minutes, and I think that's right. Could be wrong. We'll keep playing with it. We'll keep looking at what our term looks like. We'll make adjustments. Can only work with the time we've got. Okay, we're up to cubic functions. Identify the coefficient and the degree of a polynomial. Expand quadratic and cubic polynomials from factors. And we got this other one that's like recognize and determine features of the graph. We've got solve cubic equations and algebraically in cases where the equation is factorized. We've already done that. We did that previously. So that's kind of, let's pretend that's not there. And then we've got model and solve problems that involve cubic functions with and without technology. So what do I find interesting here? I find it interesting that there's no explicit dot point that says what the quadratic one said, which was sketch. So there was an explicit dot point in quadratics, which was sketch. Why is there no explicit dot point here for sketch? I'm not sure. Do I feel like I need to be able to sketch cubics? Possibly, yes. Maybe yes. But I think we can be smart about the kinds of cubics we want them to be able to sketch, right? Because in the future, when we start doing derivatives and things like that, probably the key skill we learn is being able to sketch a quadratic and find its turning points. So do I think it's worth spending a lot of time trying to sketch quadratics when I don't have that key skill at the moment? Potentially not. So let's not get ahead of ourselves. What have we done? We've done the binomial there. So diagnostic and then the binomial, and then we've got 1 day left in our week where we can do identify the coefficients, expand the quadratic and cubic polynomial from factors. We're expanding brackets, and we can revise solving cubic equations using technology. We can probably do that as well. So we can do this, and we can do this all in a single lesson. All right, so I've got it pasted in there. And so then, week 5 is a little bit of everything. It's diagnostic, it's binomial, and then it's cubics as well. And we'll knock over cubics here. So what do I do next? Well, I'm going to do recognize and determine the features, including shape, intercepts, and behaviors. So we can do this as we can take this to mean sketch the function, I guess, is what we can probably take this as. We've got y equals x cubed. We've got y equals a x minus h cubed plus k. I think this is an interesting one and one to focus on, right? Because this one tells us a little bit about the function work that we're going to end up doing later on. It's also not reliant on being, you don't have to have calculus knowledge to sketch a accurate graph of this. So this is probably worth spending some time on. And then we've got this one here, which is all x-intercepts. Notice there's no ax cubed plus bx squared plus cx plus d. So we don't have to worry about being able to sketch those here. Maybe if we had a calculator, then fine. So I'm going to take this dot point, I'm going to put it here on the understanding that what I'm doing is sketching stuff, right? Sketching cubic functions. Again, find the equation from a graph. Are we trying to find the equation from a graph? Maybe, but I don't know. But let's put it in there. And then we can finish off with modeling and solving problems. Again, I think there's kind of two key ideas when it comes to modeling and problem solving questions. Either a student is provided with an equation and they're supposed to look at that equation and determine like highest points or lowest points or when it hits the ground. I don't know when a cubic's hitting the ground. But find x-intercept, find a y-intercept. But also like some sort of area volume optimization style question might be the go as well, I think. Okay, well, I think that's cubic. Now it looks like it's only 1 week on cubic, but I've got 4 lessons there, 4 70-minute lessons. This one here, I don't know, like I don't really feel like it belongs, but maybe we treat it as modeling, and it sort of comes along with this. I've got 2 lessons here to think modeling. Okay, at some point I must have handed out a PSMT. I'm guessing the topic of the PSMT must be quadratics. So maybe I'm handing out my PSMT like here. Because then we can spend a week talking about PSMTs, blah, 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 blah. So we're taking a break from the syllabus entirely to just talk about how to write a PSMT. That should set them up for getting the PSMT done. So blah, 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 and they must be handing in the PSMT like here-ish or something. Something like that. Obviously, this is all very high-level planning at the moment, subject to change, etc. Okay, so that's all of that so far. We've done topic 1 and 2. We're up to topic 3. Looks like there's something weird going on with my thing, so I'll just fix up topic 3 and delete everything above it. All right, well, what's up next? We're talking about functions now. So we're introducing functions. When are we introducing functions? We're introducing functions in week 8. Understand the concept of a relation as a mapping between sets. You'll find a video on my website of like really hectic, like one-to-one, one-to-many, etc. I'm not sure that that's required here. As a mapping between sets, a graph, and as a rule or a formula that defines one variable quantity in terms of another. So I think we can knock that over on a fairly surfacey level. It's not like super requirement. Recognize the distinction between functions and relations using the vertical line test. Yep, okay, vertical line test, that's good, that's fun. Students can have some success with the vertical line test, so we'll knock that over. And then recognize and use function notation, domain and range, and independent and dependent variables. Okay, so I feel like the first 3 dot points are a single lesson here. important to sort of think about what you want out of domain and range. We're heading into piecewise functions. Piecewise functions, you sort of specify the domain for each sub-function in the piecewise function. So it feels like being able to specify a range, being able to say f of x this, here's the range, here's the domain. Here's the domain, specify the domain. I think that's kind of an important skill. I think if you end up diving into textbooks and things, there's a bunch of like questions where they're like asking you to identify like domains and ranges from really weird equations sometimes. I don't think that's the intention here. I don't think that's what we need. So I think there's a danger here to spend a lot of time getting super theoretical here where it's not required. It doesn't set them up for success. So I think I can knock this over in a single lesson as long as I'm clear that I'm not kind of just following the textbook. I'm doing it mindfully. Why am I doing the things that I'm doing? Where do I want it to take them in year 11 and 12? If you were following the textbook, you could probably spend a week on this piece alone, I think. Okay, gone. Okay, and then it just feels like maybe we can use the rest of the week on piecewise functions. Yeah, like maybe there's some domain and range spillover from Monday, so I think we can go here and put that here. And then we'll go here and we'll do modeling problems here. You know, where do piecewise functions take us? Eventually, I guess piecewise functions take us to like probability density functions. That's kind of the key idea. I think people can get like really weird with it. Let the general students worry about step graphs and things like that. You don't need to have like 10 functions in your step graph. If 3 is like hectic, open and close circles, things like that. Okay, done. Recognize and determine features of the graph, this and this. All right, so we're looking at circles, and then we've got y squared equals x, blah, and then we've got this one here. Okay, so it's tempting here to see 3 lessons. It's tempting here to see like this is a lesson, a whole 70 minutes, circles, and like sketching. And then y squared equals x. Oh, no, this has got to be a single lesson. Okay, so I think maybe what we can do is let's do 2 lessons. Let's do circles and sketching circles, and then let's do this one here and sketching it as well. So that's going to be 2 lessons. So I'll grab this dot point and put it on Monday. And I guess we're in relations territory now. And then I'll just put this one here, this whole 3 here. Oh, wait. I think model and solve problems involving relations would be totally fine here. It feels like, are you really doing a great deal of modeling problems here? I don't really think so. So a whole lesson devoted to modeling and solving using relations doesn't make sense. So I think we just treat that as extension questions to the sketching we're already doing. So I think we can get rid of that. I think we can get rid of that. I think we can get rid of that. And I think we can get rid of that. And then finally, we've got another little diagnostic here at the very end of the term. And then we can finish off with reciprocal functions. Like by now we should be noting, we should have the language of find an x-intercept, find a y-intercept. H and K are some sort of magical key point, in this case our asymptotes. So I feel like we can knock over this we're literally just sketching this graph. I feel like this is a one lessoner. What else am I doing? I'm sketching it, and then there's some complex unfamiliar questions that we can treat as our model and solve problems. Okay, and then that's reciprocal. All right, that brings me to the end of term 1, having done topic 1, 2, and 3. And so now we've got our holidays, we regroup, public holiday, and we start on the Tuesday for a single lesson. Okay, so we've got radians. What's a radian? Converting degrees to radians, converting radians to degrees. That feels right. And then this annoying little calculate lengths and arcs and areas of sectors in circles. So I feel like we can do this in a single lesson. Okay, we can get rid of those. Okay, now we've got to spend some time here. Trig, kind of important. We've got circles. Yeah, there's a lot here, right? Understand and use the exact values of cos this and this. Sketch graphs, recognize, sketch, solve. Okay. Interesting. There's a lot of different versions of this that you can go with, but I am gonna kind of approach this maybe in this order. I was tempted to sort of move solving trig equations up to here, but I think maybe we should let them sketch the graphs, because then they can understand why they're solving the trig equations, because if they solve the trig equations, they can find out what the value of y is when x equals this, and they can find out the value of x when y equals this. So I think we're going to focus here on understanding the circle definition of cos theta sin theta and find the exact values of things. Okay, so that's going to be a lesson. Put it here. Won't work for me. Important to note, it feels like it's big, but for 70 minutes, but literally it's this dot point and this dot point. There's not solving equations here, there's just finding the exact values of sine, cos, and tan of multiples of pi and 6 and pi and 4. So I think I can knock that over in 70 minutes. Sketching graphs, we should be getting super good at sketching graphs. So we should be able to sketch our graphs. I don't know. Yeah, let's sketch our graphs here. But then let's assume that trig is messing us up, so we just add some fat in here. Maybe we need 2 lessons to knock over this. Maybe these 2 lessons are actually getting spread across 3 lessons or something. Okay, so that's sketching these graphs. Sketching, recognizing and determining, yep, okay, and this. All right, so solving trig equations. Yeah, solving trig equations takes time for sure, particularly because it includes the Pythagorean identity. So let's put that here. And I'll just do a repeat maybe. Can I do it again? Yep. So we're solving equations over 2 days, 2 lessons. And I've also put fat in here. I don't know, maybe I have to remove that fat. Who knows? Model and solve trig equations. Yeah, let's do some modeling stuff here. All right, so what have I got left? Now we're coming to a bit where we've got to count our lessons. I think I've got 1, 2, 3, 4 lessons, and then my hope is that I get 3 lessons in revision and then the exam here. So, is it doable? Use the concept and language of outcomes, sample spaces, and events as sets of outcomes. Use this language for intersections of events. Use everyday occurrences to illustrate sets, blah, blah, blah. Well, I don't know what I'm doing there. What am I doing? Drawing Venn diagrams. Okay. So all of those first 3 dot points, barely a lesson. I'm really just drawing Venn diagrams. And, maybe I use this time to revise some like basic probability from year 10. So let's treat this as a single lesson, but maybe understanding as well that I'm going to use it to revise tree diagrams or something like that. Okay, all gone. Okay, what have I got? I've got 1, 2, 3, 4, 5, 6, 7. I've got 7 dot points that I hope I'm going to be able to fit into these 3 lessons. Let's see. Use the rules. Okay, this and this and this. All right, so understand the notion of a conditional probability and recognizing, okay? All right, so use the notion of this. All right, so I have, all right, so I've got some key ideas. I think maybe conditional probability deserves its own lesson. So let's go use these rules. So this is going to be one lesson. Independence, independence, independence. Okay, so all of the independence dot points are a single lesson. And then model and solve problems. Okay, let's work backwards. Model and solve problems we'll put here. Independence is a single lesson. And so again, textbooks can go to the ends of the earth with this stuff. But if we look at the dot points, there's not actually a great deal of stuff happening. Okay, so they're gone. Now, what did I put here? Oh, that's language stuff. It's possible that this one could go into that lesson, but no, I think the whole thing here, I've kind of backed myself into a corner. This whole thing goes into a single lesson. Okay, so I think what I'm going to do, that's everything. That's the whole thing. And I'm not super happy with just that final little piece. So I think maybe we'll treat this revision not as revision, but we'll treat it as FAT instead. To me, that's fine. Where have we been doing diagnostics? We've been doing diagnostics here, here. So we should have a good feeling for how these students are going leading up to this exam. We've got FAT here, so might be able to use that FAT for another diagnostic. We're collecting stuff as we go. I think that's it. I think that's my plan. And I don't think it's a wild plan, but I think like as long as I'm very clear on what the syllabus is asking for and what the syllabus isn't asking for, then I think I can get it done from week 1, exam in week 16. How much fat have I provided myself with? I've got 4 lessons of fat. So over and above the lessons I've already lost, if I lost 4 more, I guess that fat can get constricted a little bit. I also think that this one, finding the equation and finding the equation from a graph, that language isn't in the syllabus. So maybe these are also fat. Maybe they get included in the modeling and problem solving questions. So every time I've got a finding equations one, the lesson after it is like model and solve problems. So maybe find the equation gets folded into model and solve problems. So I think I do have space there as well. So I think I've got 1, 2, 3, 4 bits of space there. I think I've got another 2 bits of space here where things can contract a little bit. I've probably also, and maybe not, but I think I've also maybe got a little bit of space here. Because I've broken up solving quadratics into 3 distinct sections. Should it take 70 minutes to cover the quadratic formula, which is very plug and play, and the discriminant? I don't think so. So, okay, the next step here for me would be doing the same for Unit 2. If I do the same for Unit 2 and it turns out that I run out of time, I want to finish Unit 2 by the end of Term 3, then I guess I've got to revisit this again, try to shift things a little bit. But I think it's possible. After that, the next step would be looking for my resources and getting a true sense of, am I being realistic with all of this? But I think from experience, I am being realistic with all of this. But that would be the next step after that. Okay, so I hope that was useful to anyone who's thinking about 2025 and how to fit all of their stuff in. Obviously, you might not have 3 70-minute lessons. You might have somewhat different amount, but the process, the thoughts behind it, I hope some of that was useful for you. Let me know if it was useful. If you want me to do Unit 2 just like this, I can do that. All right, catch you all.